Alright, now we're back with part 2. So, now we look at the create branch element, and we notice how if the way our branch value is equal to 0, then it sets the way PC to I count. Well, here's a change we're gonna make. First, let's separate it into these 3 brackets. And here's some example code. So, in one where that goes way 256, it calls into where branch equals to 0, which then the index of the new branches object is going to be equal to nums0, which in this case is 256. And then branch equals, where it compares two registers to see if they're equal, and then the index, and that's going to be calling where branch equals to 1, and so here it equals to nums1. Well, it might be more convenient to do a int toIndex. Set it to -1 at first, and then move this down, and then toIndex equals 0 over here, and then over here it's toIndex equals 2, then .nums toIndex. And then lastly, if we use a branch not 0 instruction, it's just going to contain 1 register, and then the index, so in that case it's nums1. So we're going to have to actually add another where branch value, number 2, and then yeah, it's still branch PC, and then to index 1. Right, and let's save it here. Now you go back into the main function. So one problem that actually exists in when I try to run the program is that it's not detecting an index of a branch object that's already inside the branch array. Right, so now in the main C file, we're going to find any part where it creates a new branch element. Right, and over here, let's add this if statement. If the string compare the up b and z is equal to 0, now let's actually add another integer for convenience. Int b and z equals, and then string compare. So then if b and z is equals to 0, then it's gonna call create branch element 2, else create branch element 1. And the reason I'm doing this is so that b and z, when the instructions b and z, the index will always appear at number 2, which is nums1, whereas with beq it's going to be at nums2, and then for way it's going to be at nums0. So let's go back into the main method here. If b and z equals 0, and yeah, since nums1 is going to be the index for the current instruction, and then it compares it to branches, branch count. So now let's test our program. So now what happens, we get the correct index, but now instead of adding a branch PC to waypoint 0, it now instead creates a whole new waypoint, which is the branch object. So now let's go back to the code. Oh, and we're also going to want to make it display both the waypoint PC, let's call it WPC, and the branch PC, let's call it BPC. Alright, branches j dot branch PC. Here's the thing though, I recently reset this computer. Okay, so in the first time around where it says waypoint 0, it doesn't have a branch PC set to it yet, and then at waypoint 1 where it creates a whole new one and doesn't have waypoint PC set to it. Alright, so now let's see what's going on. So create branch element, which creates a new branch element, is constantly being called on for some reason. So let's look at create branch element. And yeah, for when it uses the branch instruction, wayPC isn't going to be initialized yet. But first we'll see if there's a problem with any of the earlier parts, such as it finding the correct index, branch array index. And branch array index is initialized here to -1. And then yeah, once it gets to the branch instruction, the if statement, and then in this for loop where it looks through all the branches inside the branch array. And then in our case, ours is b and z equals 0, but it doesn't seem to match the equals index here. So let's add a printf, because this is our way to manually debug a. So now if we were to run it again, okay, so it's not printing out the line debug a. Right, so it's not reaching immicount.nums1 equals to the index of this, and instead branch array index remains -1 here. Oh, I found a problem here. So it says if it's equal to branch count.index, it should say branches pack.index, since pack is the variable we're using for this for loop to iterate through the for loop. Okay, now we're going back to the branch function, and over here we see if branch type equals 6, then that means the branch instruction BNZ, which means branch not zero, which is the one we're using in our sample. And we're going to make it so that if the register amount gets further away from zero, then it's going to decrease the HP. HP minus equals 1. First, we're going to have to find a way to make it detect that difference. So it's not equal to 0. And then over here, if registers inst nums 0, now if it's greater than before, so we're gonna have to actually keep a record of that somehow, is greater than the previous. So we might actually have to add another variable for branch. Okay, branch elem, and then we're going to add an integer called int prev amount, which is the amount, the previous amount of the integer of the difference between the register values. Instead of prev amount, let it be prev diff. So then we go back down if prev diff, well, if something is greater than prev diff, so in this case if registers inst num 0 is greater than prev diff, HP minus equals 1, and then prev diff equals to that same number. And then if HP, well, let's actually move it to a different place. So over here it's going to say if HP is less than or equals to 0, then the exception value, which as we mentioned earlier, exception handling, so the variable is called exception, is going to equal to 2, and then yeah, it'll say else if and then all of that. Right, so as you can see, the variable HP, now since this isn't referring to any variables declared in here and is instead referring to a variable inside the branch element, which is a branch object, then it's going to instead, now the instruction is branch instruction inst, and branch is I, and let's see where I is declared, because first it's initialized to 0 here, and then for int branch count, yep, so branches I, if branches I.hp is less than or equal to 0 and exception equals 2, and find anywhere else that the HP was manipulated, So yeah, branches I HP, branches I dot HP over here, and then save and then run the program. But first, yeah, find prev diff right here, branches I dot prev diff, then save, and then run the program. Alright, so now, yep, this is a step in the right direction. Now it's only having the one waypoint, index 256. But then it gets stuck, and then we're not sure where exactly it gets stuck. So let's go back into the program, and then right now that I'll actually pause the video and then do some behind the scenes debugging to find out where the issue is. Alright, so it turns out, yeah, now I've moved this line of code down here to the bottom, and then instead of branches I, since I is only used in these for loops, then since it sets dest equals to I, this should say branches dest.hp. And yeah, if branches dest.hp is less than or equal to 0, it'll return an exception, then printf exception. Yeah, so let's save. And then over here it says program finished with exit code and then exception. Okay, and then if exception is equals to 1, that's the exception we used for not being able to find the file. So now it's going to say printf file not found, and it's going to have printf, let's start with, and then a new line, and then in capital letters exception, and then a new line, and then if it equals to 1 it says file not found exception. Could not find the file specified, and then new line, or actually let's put the new line right before program finished with exit code. And yeah, might as well put 2 new lines. Alright, and then we're going to do exception equals 2, which is for the one we're doing just now about branching and then infinite branch. So then it's going to be called infinite branching, infinite branching exception. And yeah, I might as well put a space between each. And yeah, this first part might as well just be a plain old new line. So there's file not found exception and infinite branching exception. And then branch instruction to be branched infinitely. So now when the program detects that a branch is gonna run infinitely, it's gonna stop the program and return an infinite branching exception. Alright, now we're gonna go back down and then make some more changes to branch. Now, see if valid branch is equal to 1. Instead, we're gonna change it to if it's greater than or equal to 1. And then over here it's going to say valid branch equals to 2. And then cut and then paste. Then first you'll notice here it says inst.nums2 and then it gets changed to inst.nums1. Now we're going to change it to 3 minus valid branch. That way this number is equal to 1 if branch type is 6, and then it's equal, well, minus, and then it's equals to 2 if branch type is anywhere from 0 to 5. Alright, and then if registers, okay, so in this case it's going to be if branch type equals to 6, oh, and yeah, and then we won't need this part, which I use just for manual debugging. Then we're gonna need another int here, let's call it diff. Right, prev diff equals registers. So this is for branch type number 6, which is the previous difference right here, prev diff. Then we're gonna make it once for every branch type. So yeah, if branch type equals 0, and so that one is BEQ branch equals. So it branches if it equals. Now where's diff gonna come in handy? Well, it's gonna, so diff in this case is just gonna be equal, well, let's look at the branch type equals 6, valid branch equals 2, which means this one is branch not 0. And in this case, diff would have been equals to registers nums 0. So in this case it'll say and diff is greater than prev diff. Copy, paste, and then branch type equals 1. In this case is where they're not equals to each other. And then, so for branch 0, and in this case if diff is equals to previous diff, so then in this case diff will equals to, well, let's go up here, then say diff is equals to it registers inst nums 1 minus registers inst nums 0. Okay, so as you can see here, I've added ABS, and that's the function that's already included in C. It's used for absolute value. So now it takes the absolute value of the difference between registers 1 and 0. Okay, so let's rework this part. If branch type is equal to 0 and then the difference between them increases, since branch 0 equals is for BEQ, branch equals, and then yeah, it reduces the HP prev diff is going to equals to diff. Alright, and then now if branch type equals to 1, and since this one is branch if not equals, and then diff is equals to 0 in this case, then yeah, it reduces HP and it's not actually going to matter here, but we'll go with it anyways. And then branch type equals 2, and yeah, I'll continue doing this for all of these branch types. Oh, and the part where it creates branch element, be sure to also initialize the prev diff simply to 0. Just an arbitrary number. Alright, now back to this. And here now I've made two integers diff and abs diff. Diff being the difference between registers numbers 1 and 0, and then abs diff meaning the absolute value of it, since it's going to be needed for some of these branches. Alright, now pretty much done except for this part, but instead, okay, prev diff equals registers num 0 and registers num 0 is greater than branches prev diff. Right, now let's save and then test the program. Alright, and then yeah, remove valid branch equals 0. Shouldn't really be on here anyways. And then, alright, now let's save and then run the program. ECC main.c, right, no errors, and then clear a.exe for loop.text. Yeah, infinite branching exception. So next, what you should do is try it with various other assembly codes and then see if you can get the correct output every time. And that's exactly what I'll be doing behind the scenes. And then for any changes to the code that I make, it'll definitely be in the branch function, which is right over here. And then I'll update you on the next part of this video. Alright, so that'll be it for part 7 of the assembly code simulator. And we have completed exception handling. And yeah, see you then. But also, I'll be making another programming series about data structures, and it'll definitely start with part 1 being about an array list and then part 2 being about a linked list. Future parts will be about various other data structures, so stay tuned for that series as well. Right, Umongus signing off.